Hi guys, welcome to my YouTube channel. Okay, so what we are going to see today is Python's very important concept, which is standard library modules. Okay, you can say library modules. So we are going to see one library module in this video. Okay, and further more videos we will deal with the other library modules. Okay, so first thing you have to know what is a library module. Okay, so what is a library module? It's like we have certain modules in Python. Okay, those modules are inbuilt. Okay, underline this word inbuilt. That inbuilt modules, okay, it is not user defined. Yeah, as I said, inbuilt. Those inbuilt modules we have in Python for holding certain specialized actions. Okay, so actually modules are something where bundle of functions or bundle of variables or constants we have inside it, and those modules can be used inside your program. Okay, by just importing the module name. Okay, and I'm importing that module name inside my program, and I can able to use the functions whichever already inbuilt inside that module. Got it? So see, again I'm repeating. So actually modules are something which are having functionality for specialized functions, okay, that are inbuilt in Python. Okay, for instance, okay, we can take we have a module called time. Okay, what that module will do is if you are importing that module, okay, module time inside your program, you can able to deal with all the time related functions. Okay, you can able to use all the time related functions inside your program. Okay, you no need to do all the calculations that are mentioned inside the program. You just call that function which is already built in inside your time module. Okay, so we can go with a bookish answer now. Actually, so other than built-in functions, standard library also provides some modules having functionality for specialized actions. Okay, which I already mean, right? Okay, here in a Python module, actually this is a file, okay, that contains some variables and constants, some functions, objects, etc. defined in it. Okay, understand this. A Python module is a file which contains some variables, okay, constants and some functions, objects, etc. Those are all defined in it, already defined in it. Okay, these can be used in other Python programs. So we can, if we are in our program, if we need those functions or those variables or those constants, okay, so in our program, if we are in a need of those things, you can directly use it in our program. Okay, so how I can able to use it in my program? So in order to use the module, you need first import the module in the program. Okay, this is my first point. Okay, I have to import that particular module in my program. Okay, and then we can use this module functions or variables or constants and other objects in my program. Okay, fine. So here in our case, we are going to deal in this video, we are going to deal with math module actually. Okay, so before that we also have to understand we have some modules they are mentioned here. Like we have a module name called time, so that offers time related functions. Okay, we also have a module name called a string that offers functions for string manipulations and so on. Okay, yeah, fine. So now we are getting into math module. Math module is like the keyword math will be used. Okay, so this is a module name. So before we are using any mathematical functions, fine, so which are inside this math module, Okay, I just want to use import math. Okay, import math at the start of my program. Fine. After that, if I'm using any functions inside this math, I should go with the syntax math dot that particular function name which I'm in need of accessing. Okay, math dot function name. Okay, so here are the sum of the mathematical functions inside the math module. Okay, so first function which we are going to deal is ceil, math dot ceil. So ceil is actually a function. So to access that function, you are supposed to use that module name in front of it. So math dot ceil. So inside the bracket, so inside the function bracket, you are supposed to provide the number for which this ceil operation need to be performed. Okay, what this ceil actually does, okay, actually this returns the smallest integer. That's it. Okay, this returns the smallest integer. Okay, what is the smallest integer? How come you are saying this is the smallest integer by comparing anything? So that is a thing over here. So it returns the smallest integer not less than the number. So you're providing our number to that you need to perform ceil, right? So that ceil is like, for example, math.ceil 1.03. So what is the integer over here is 1, right? So I need to perform smallest integer not less than the number. So actually this is a number, okay? But I need to give a value. I need to get a value that should not be that should be integer. Okay, that should be integer. Okay, but that should not be less than this 1.03. So I won't say like 1.04 is an integer, 1.05 is an integer. No, right? That is a float value. But I could say like 2 is an integer, 3 is an integer, 4 is an integer. It goes on. Okay. At the same time, before value 0 is also an integer. But I'm clearly saying that integer should not be less than the number. So the number is 1.03. I need to provide an integer that should not be less than this 1.03. So obviously I go for 2. Right? So that should not be less than the number. And it should be the smallest integer. I should not say like 3, 4, 5. Those are all the answer for this ceil. No. Why? Because the integer should be the smallest integer. I can give like 1 is the smallest and it should not be less than that number, right? So I should give above 1. But that number should not be the greatest integer. Okay. I should not give 3.0 because this is not the smallest integer, because I already have before this 3 I have a 2 as an integer, and before that only I have 1. So it should satisfy 2 condition. Okay, first condition is that particular number should be greater than this number. Okay, and the second condition is this particular number should not have any more smaller integer. Like if I choose 3, you can say like 1 is 3 is greater than 1. That is true. But at the same time, you cannot say this is the smallest integer, because we have one more integer 2 before this, that is the smallest integer. Got it, right? Fine. So for the negative number, it goes like minus 1.03, it gives minus 1.0. Fine. Next thing is SQRT function. It is used to find out the square root of the number which has been given inside the function. Fine. If the number which you are providing here is less than 0, it throws an error, which is domain error occurs. Okay, here domain error occurs. Then a function called exp. Okay, this function, what it returns is it returns the formula for e square, what the value you are getting. I mean, if you are getting exp of 3.0, then e cube. So this is an logarithmic function, natural logarithmic function. So you'll be getting, if in case your program needs this particular logarithmic function, you can directly go with this exp function. Next, fabs, you can say like floating point absolute values. Okay, you are just getting the absolute value for this particular number. So 1.0, so see, actually absolute number is something which is without negative number, okay, without negative sign. If I want to be more specific, the minus sign should be removed over there. So minus 1.0, it gives 1.0. Okay, so fabs is okay, right? Now floor function. What is the use of floor? Actually, ceil and floor, they are like you can say like brothers. So here what did I say? It is like ceil, it returns the smallest integer that is not less than the number, but here it returns the largest integer that is not greater than the number. So for example, 1.03, I should not go like above this number, because here it is not less than the number, here it is not greater than the number. So 1.03, the integer is 1. I should not overcome this 1, okay, and at the same time I should not go beyond the 1. The reason is because that should be the largest integer. See, for instance, here 1.03 was my number. I should not go like 0 is my answer, because 1.03, you can say like see, 1.03, before the integer is 1 and then only 0. So here I said the largest integer need to be there. So this is the largest integer comparing with 0, but this particular integer should not be greater than 1.03. Yeah, right? It is not greater, right? So likewise negative sign also. So minus 1.03, it goes minus 2. Okay, so minus 2 was the largest integer, and that is not greater than minus 1.03. Fine. So next function is like math.log. So here is like you're finding the logarithmic function, that's it. So log of 1.0, so you can give base also, okay, base number 2, 4 or 8, something like that. So based on that, the logarithmic calculation will be performed and the output will be returned. Okay. Okay, next these are some of the functions which we will be using in our program. This power, POW, this function will be used frequently. So actually this contains two parameters. Okay, one is your base, the other one is your exponential parameter. Base is like, so 2 comma 3, it means 2 power 3. This is what you are trying to perform in your particular program. Okay, so here too we supposed to have certain errors where this particular base should not be 0. Okay, and this particular 3 should not be 0 or less than 0. I mean, the exponential case should not be 0 or less than 0. The base should not be less than 0. So these things are supposed to be taken care of. Then math.sin, cos, tan. Okay, these three are trigonometric functions, okay, which will be used whenever needed. Based on the trigonometric table values, these three functions will be acted upon. Next thing is like degrees and radians. So degrees is like the radian value will be converted into degrees. Okay, these things actually deals with the angles. Okay, radian, if you are in a position where like you are supposed to convert the radians to degrees, then you can go with these degrees. Then you are in a state where the degrees will need to be converted to radians, then you can go with this function. Okay, so with the help of math library functions, with the help of math module functions, so we are going to discuss about one example program. Okay, so here they have provided the radius of a sphere is 7.5 meters square. I mean meter, radius is being meter, which is you can say like r, something, some variable, 7.5 meter. So I need to write the Python script to calculate its area and volume. So area of a sphere we have a formula. So area is equal to pi r square. Area of a sphere is pi r square and the volume of a sphere is 4 pi r cube. Okay, so I supposed to use this input math module. Okay, and they have given area as a sphere of which has the radius 7.5 meters. That is r is equal to 7.5. R is a variable which holds the value of 7.5. So area formula is actually pi r square. So math dot pi. So it is not like that math module will have only functions. Okay, it also has some variables or constant values. Those values are math dot pi. You also have one more value which is math dot e. So those things also present inside this math module. So to use this pi value, math dot pi you can use. So like so that is how the area is equal to math dot pi dot r into r. Volume is equal to 4 into math dot pi dot math dot power of r comma 3, which means like this r is your 7.5 that acts as a base and q. Fine. So everything will be calculated and stored inside this volume. Now the area will be printing with the help of print statements. I'm just printing this area, volume and this radius. That's it, with some units. So obviously area will be with unit square and volume will be in units cube. So thank you for watching. Please do share and subscribe my YouTube channel.